Hi, I am Siddharth Singh. I am having total 11 plus years of IT experience across different technologies. Currently, I am working as project lead. From past couple of years, I am working on big data and Hadoop technologies. Today, I am going to walk you through my complete training course built around big data and Hadoop. So to start with, I have made my training course such that the participants are more engaged through assignments, quizzes, asking questions so that I prompt them to ask more and more questions. And along with that, I emphasize more on basics and fundamentals rather than going into higher level example or higher level use cases. So I try to give the use case which is more close to our real world on in the real IT industry, so that a person feels more confident and able to connect better with the examples and the use cases. So to start with, the chapter one, which talks about understanding of big data and the Hadoop. So before we really talk something big, we'll get into our basics first, which is what is data and how its growth from several years. Then we'll talk about different types of data we have in our surroundings, like we see these days we are having text data, audio, images, based on the different types of systems doing, like the online systems, retailing systems. So based on this, we are having different types of data all now. Then we'll move into the big data, that how and when this data turned into something big. So, like as we understand, big data is not a special kind of data, it's still a data with some specific properties. Then we'll move on to Hadoop, because Hadoop provides a solution to solve the problem of big data. Then we'll move in, like, why Hadoop? Why Hadoop is the best solution to solve the problem of big data? Why not there is some other solution? Why traditional systems are not able to solve the problem of big data? We'll see the difference between Hadoop and the traditional systems. We'll discuss about like distributed storage, distributed processing, and all. Then Hadoop history, because few participants are really interested to know about the history, how it invented, who invented it, originated. So then we'll move into the complete architecture. In architecture, we will see all the components of Hadoop and how these components like Hive, Pig, MapReduce, how they are interacting with each other. Then we'll move into the Hadoop daemons, the different types of daemons and the background processes running on the Hadoop cluster, and how they talk to each other to give them the better understanding about the complete Hadoop architecture. Then we'll talk about the two pace of Hadoop. One is the processing model, one is the storage model. So we will discuss both models separately in detail. So like processing model is a MapReduce model, and the storage, again the distributed model, is Hadoop distributed file system model. Then we'll discuss about the various Hadoop distributions in the market, like Mapr, Cloudera, Hot and Works, and which is used more and why each one is important, or what's the specialty of each distribution and why we are having those distributions. Then we'll move our chapter 2, where we will talk about the architecture and Hadoop storage. This chapter is strict to the only storage, Hadoop distributed storage. Here I will not going to talk about the processing part. I have kept separate chapter for processing, separate chapter for storage, to keep it separate and participant can understand it better. So then I will talk about Hadoop 1.x cluster architecture in terms of storage, that how the data is being stored in 1.x cluster. Then we'll talk about the Hadoop running modes, that what are the different types of modes in which Hadoop cluster can run. We'll talk about HDFS architecture and the benefits. Then we'll talk about this, especially HDFS architecture, and what are the benefits over the traditional file system or the traditional storage systems. Then anatomy of file read and write on a cluster. This will be kind of logical flow, like when a client puts a request to read a file or write a file, how the request flows client or from client to the name node, and how it goes to the data node, and how the client interacts with the data node directly and all. So it will give a complete and detailed flow and anatomy of a read and write. Then we'll see the interaction of HDFS from command line, like how to move the file from our local system to our SD file system, how to change the permissions, how to get the file, how to put the file, and all. Then the limitation of 1.x storage system. Then we'll move into the 2.x cluster architecture, and then differences in 1.x and 2.x, and how 2.x solve the problem of 1.x. Here I'm still covering 1.x because people are still talking about during the interviews, or if you go out, people are still asking questions on 1.x. So I want to give learning on 1.x as well, so the person is more confident how the 1.x was used and now how 2.x is better. In chapter 3, we'll go for processing, like chapter 2 was storage, now we have processing, which is a MapReduce model. So we'll talk about the MapReduce model, what is this, and how this distributed model helps to process the big data. Traditional way of processing versus MapReduce way of processing, architecture of 1.x MapReduce model, and in this architecture we'll talk about like the interaction of all the daemons while processing a file on Hadoop cluster. We'll talk about limitations of 1.x processing model and architecture of 2.x, and then we'll go with the anatomy of a MapReduce program on Java. So again, in this anatomy, we'll see the logical flow, how a program flows from driver to resource manager to application master, and then how the program launches in container and taken care by node manager and all. So here we'll see all the logical flow and how they interact with each other. Then we'll see the relation between the input script, which is a processing unit, and the HDFS blocks, which is a kind of storage unit. So till now, I haven't touched the Java programming. Next, I will move into the chapter 4, Hive. So yeah, so once a person is kind of confident about big data, Hadoop, architecture, anatomy, storage, processing, I really don't want to get into the Java programming at the same point, because a lot of people are really not aware of Java and their confidence level may become low if I start Java, and they may not be able to understand the thing completely. So I don't want to get into directly into Java programming, which is kind of low level programming these days. So better to start with the Hive, which is a SQL interface to interact with Hadoop, so that participant may feel more familiar, and the confidence level will be kind of high because he may get a confidence that he can still learn and still able to run the jobs on Hadoop cluster using Hive. So like Hive is a kind of SQL interface to interact with the Hadoop, and by writing SQL queries we can submit our Hadoop jobs and process the big data. So we'll start with the Hadoop background, evolution of it, and the use cases. We'll go with the Hive architecture, what are the different components, how it flows, what are the different types of metastore in Hive, how it stores the metadata, uh, differences with our traditional RDBMS, how the Hive database is different than our traditional relational database. Different data types in Hive. Then we will go with like internal or managed tables and external table creation and the DML executions on Hive tables. We will see the various data loading techniques in Hive tables. Then the creation and execution of SQL statement will try to execute a lot of Hive queries on CLI and also through our HQL scripts as well. So then we'll see functions and joins in Hive, different types of functions and joining criteria we have in Hive. We'll go with next the partitioning and the bucketing, and then with the user-defined functions. So this will cover most of like our Hive again with the assignment, which is a hands-on. Moving to the pig, pig is again a kind of high level, I would say, scripting language. It uses a pig Latin, which is a more again like kind of SQL as well, which is easy for a programmer to understand. So we'll start with the pig, with the background and evolution of pig, why pig and use cases, why we are using pig instead of like MapReduce, why most companies are preferring to use pig. Difference with MapReduce programming, different running modes. What are the different types of modes in which we can run pig? The data model and the data types we have in pig, and then we'll move into the pig programming on loading the files, transforming, and then storing the result. Then we'll see various operators like join, co-group, union, filter, etc. Then we'll go with the built-in functions, and then we'll see the programming user-defined functions. After the pig, moving to the chapter number 6, Scoop, another important component in Hadoop ecosystem. We'll start with the Hadoop Scoop introduction and the architecture and the flow. How to create table in RDBMS table in MySQL or Oracle, and then how to import and export the data from RDBMS to our HDFS using this Scoop tool. And then we'll do a quick recap on Pig, Hive, and Scoop and what are all the differences. Then we'll move to the NoSQL database, HBase and the MongoDB. HBase is a column-based NoSQL, MongoDB is a document-based NoSQL. So we'll study both so that participant may have better idea on both type of NoSQL databases. So we'll start with what is NoSQL database, then difference between the NoSQL and the SQL database. Move with HBase introduction, architecture, and the use case. And we'll see various operations on HBase and the commands like how to create table in HBase, how to insert the data, how to get the data, what are like how the data is versioned in HBase. Then we'll go to the MongoDB, which is a document-based NoSQL. So we'll see how to create a database, collections, and documents in MongoDB. And we'll try to insert, modify, delete the documents in MongoDB. So by this way, participant will get enough idea about using the NoSQL databases. Chapter number 8 will talk about the MapReduce programming, which is a kind of low-level programming language through Java. So that's why I kept it in a very last section. So till now, participant will be, feel more confident, confidence level will be high because till now he has already run few jobs on Hadoop cluster and understanding about Hadoop and all. So now we will introduce MapReduce programming. In MapReduce programming, we'll see the MapReduce example flow word count program. So before running this program in Eclipse or in Java console, before that we will see the complete logical flow, how the MapReduce job really process a file by like how the record reader reads the file, then it goes to the mapper class, then it goes to the map function, and then how the key value pairs are passed among these, then it goes to the framework sorting, shuffling, and then reducer, and then how the result is stored in our HDFS. So first we'll see the logical diagram of all these things in terms of key values, and then we will move into the actual programming in Java console. Then we'll move on like partitioner, combining different types of zipping methods we have performance improvement techniques. Then chapter 9 will deal with the Flume and Uzi, where we'll talk about introduction to Flume and Uzi concept. What are the use cases, why it is being used. We'll schedule a job in Uzi, we'll create a job in Uzi, and we'll set up a configuration file in Flume, and we'll see how the streaming takes place in Flume. Chapter number 10, Spark and Scala. Spark is a kind of total separate framework than Hadoop framework. So, and Spark is mostly written in Scala, which is a object-oriented and functional language. So we need to have separate understanding of Spark and Scala. So we'll start with the introduction of Spark and Scala, understanding of Spark framework, and what was the need of Spark and use case. We will see the difference between the Spark framework versus Hadoop framework, discuss in detail about Spark architecture. We'll talk about RDDs, Resilient Distributed Data Set, which is a kind of basic or base model to do coding in Spark, how to like create an RDD, how to transform an RDD, how to generate an RDD, how to get the result in the form of RDD. We'll see all those things and we'll work on programming in Spark. In chapter 11, we will do a quick recap of all the things that we learned in the previous chapter, and we will see the industry real project flow, that how a real project really flows in IT industry, and what is the complete process, like how a person raises an access, what are the different types of nodes we have, and how the job is submitted from our client program to the cluster, because what we read through our online program or through our books is little bit different than what we at our organization uses and submits the job and gets the output. So we will see the like kind of how the things flow in real sense. And apart from that, we'll also work on a project using all these modules. So I guess that's all about it, my training course. And thanks for watching the video. If you have any other questions, then let me know. Thank you.